So it seems that we are starting 5 minutes late. So we have to win time. So I'm gonna ask, okay, to all the people still in the lunch trying to go back here, okay, as soon as possible, so we can catch it up, okay, with timing. In any case, I'm gonna do a really short welcome. Okay, I really thank you all for being here, for all those persons online. So I'm really grateful, okay, to that the community of digital twins in the built environment, okay, it's growing, okay, and that we are trying to find compromises and things that we can do in the future, okay. And I think a good example of that is the two sessions that we have today, okay. First, focusing on new European projects, conclusions of projects that are finishing, also use cases, okay, and case studies that we could find everywhere, okay, across Europe, but also in the world, okay. I think it's really important to see and to get as an example to learn things, okay. And the second session, trying to dig a little bit deeper in terms of interoperability, in terms of how European Commission is tackling with data spaces, okay, and try to understand even from other disciplines, okay, how they are tackling with the new great thing, okay, which is how we can merge data to get wisdom, okay. So thank you so much for being here, okay. So actually, let me introduce Angelo Ciribini, okay, our first keynote speaker. Angelo is professor of University of Brescia, and also is the convener of the working group 8 about capabilities inside of the technical committee for FO2. Thank you.
Good afternoon, ladies and gentlemen. First of all, I have to apologize because I am forced to leave just after my speech. But anyway, so thank you very much, Edward. So I'm convening the working group 8 at the CENTC 442 titled BIM. Our own common boss is Øyvind Roth from Norway, who is also chairing the ISO technical committee. But so my working group is dealing with maybe competencies and competencies, because of course our own friends from UK are distinguishing between the word with or without I. Different meanings, and of course semantics are coming back again. So originally we did decide to establish the working group in 2019. We were in Prague, and we did decide to start to establish some working group just before the 9th working group. And we did start and we were devising to maybe issue a standard. But quite recently we did move from the standard to a technical specification, because we have to reach the widest consensus, as wide as possible consensus. So, and the working item is titled Professions and Competencies Related to the Information Management. And so we did recently internally issued a report on the last February, edited by myself, Mark Baldwin, who is also representing Business International and the Swiss standardization body, and Lucy Schwankombeva from Czech Republic. And so our own intent is of course to try to I'm also part of the working group 9, to be honest, but of course our own intent is to strengthen our maybe links and relationship together with Edward, of course. And so we did meet since the December 2021 20 times, so we did hold 20 meetings plus 3 workshops, because of course we have to reason about the states of the art over the Europe, and we did involve also the European community and the European Commission, namely by means of Peter Stellens. And of course, we did try to start to reach the consensus. It's not so easy, of course, but I think that we will succeed on the near or on the next future. So the new working item will maybe expire more or less in 3 or 4 years. So we are not in a hurry because we have to reach the consensus. But I think that it could quite important to maybe provide a technical specification to be acknowledged over the whole Europe, not only within the borders of the European Union. And of course, we did work quite hard in order to prepare an internal position paper on the last year, because we had to maybe recognize, to acknowledge the national differences, and of course to maybe devise a sort of non-prescriptive general framework. But of course we did start from different sources, including the German VDI guidelines. And nowadays we are establishing the main contents of the document, from the introduction, of course, throughout the framework standards, existing competence initiative, etc. And of course we could include within the document some maybe high-level implementation guidelines, and within the national annexes we are foreseeing to, of course, maybe introduce some conversion tables dealing with the titles, roles, jobs, and functions, because we have to avoid to mention them within the document. But I think that we could also take into account the digital twins in the built environment, starting from, of course, the general standard recently issued about the digital twins, about the concept and terminology. And of course, we are starting under the convenership of Edward to maybe write and perform a similar document addressed towards our own topic, the digital twins concept and definitions. But I will leave the floor to Edward in order to explain the additional item. But I also to highlight that some days ago, as Aitor was highlighting to me as well as to Edward, the recent new directive dealing with the energy efficiency of the buildings is mentioning the smart readiness indicator for buildings to be sided to the digital building twin. So I think that it's a great maybe achievement. Some months ago we did discuss the topic together with Brigitte Jacquemont, who is in charge within the European Commission of the SRI. But so we are not successful, but it does depend on us. But I think that we have to be happy, of course. But the maybe original and initial maybe triggering point has been the Italian national standard 11337 Part 7, issued 6 years ago, and we are starting a systematic revision and a review of the standard. But it's a national standard, maybe depending on a national law enforced 11 years ago, and it does deal with the non-acknowledged and non-chartered practitioners. And obviously the Italian standard is mentioning the BIM titles, BIM jobs, and BIM roles, from the BIM specialist to maybe on the near future the GeoBIM specialist. But from the European point of view, we maybe from the early beginnings of our own work, we did decide to discard such an approach, because we are not able to reach the famous consensus, because there are different attitudes, different cultures, different certification schemes. For instance, the German ones managed by Markus König, more or less, but there are a lot. And of course, there is also the Builders Mark International related qualification and certification schemes. And so we did start in maybe taking into account different maybe aspects: education, training, qualification, but not certification. And for instance, it's maybe an approach hugely shared by our Finnish colleagues and some that are rightly quite sensitive to the maybe educational items. So we are not specifying any professional title or role or job at European level. We could reach the consensus and on a higher level. And we might, of course, we could also try, it depends on different maybe causes and factors, but to define some competence dealing with the digital twin management. But I have to say that the BSI, the British transposition of the ISO standard I was mentioning earlier on, is discarding the acronym DT, because DT does mean, from the UK point of view, digital transformation, as well as they are refusing to use LOIN as an acronym. And they are using DTW. So we could maybe adopt the DTW management. And so, but I think that if we are looking at the ISO standard issue on the last year, the definitions are quite interesting. And of course, we could reason in the near future, I suppose, about it. Of course, maybe the definition of the DTW is including the convergence between the physical, of course, and digital states at an appropriate rate of synchronization. But also, it does define the digital entity as a computational entity comprising also procedural elements. And of course, the modeling has been defined maybe when mentioning the symbolic paradigms and formal languages, and the information models are models of a set of facts, concepts, or instruction to meet a specific requirement. And of course, I think that on the next June, under the convenership of NCAMP, we will start to the systematic review of the ISO standards 19650. So I think that we could also rethink the definition of building information model in front of different definitions of information model. But the standard also maybe refers to semantics, semiotics, and of course ontologies. And this morning we did discuss the issue, and I think that BDTA will maybe represent a reference about the ontologies dealing with the digital building twins. So, but it's clear that if we are maybe again coming back to the standard, there are some meaningful and relevant words, and above all, I think that the most maybe overarching one is prediction, of course. So it does mean, from my point of view, that we have to maybe side and couple geospatial modeling, and for instance, we are usually working about it within our CISR project check, together with Accord and DigiChecks, and of course we did discuss the topic this morning too. And so geospatial modeling, building information modeling, digital twinning, and I think the large language modeling, or the large language models, including of course RAG, because it's clear that RAG could be the maybe crucial triggering agent as far as the larger language models are concerned. So we have to avoid any title within SEN, but I think that here we could start to reason about the title or DT or DTW manager, to be conceived maybe is of course a question not to be answered nowadays, but as a prompt designer and a prompt engineer, I don't know. But it's clear that the main topics to be considered could be listed as follows. On real-time and on remote decision-making process, modifying the behavior of the target entity, causal explanations and algorithmic decision-making process, and overall have to be included or have to be take into account the human in the loop criterion, or we could at least maybe consider the human not in but on the loop criterion, so because the algorithmic decision is quite sensitive. So thank you for your attention.
So thank you very much, Angelo. And now we call to the floor Paris Fokaides, please. And we will have the second keynote speaker with us. Thank you so much.
Thank you very much. Hi, everyone. It's a pleasure to be here with you. Today I'm going to present a project that is ongoing in Kaunas University of Technology since late 22. It's called Smart Wins. It's about boosting our research capacities in Kaunas for conducting research in the field of built environment and digital twins. And as you can realize, the acronym of the project is from the word smart and from the word twins, from digital twins, so smart wins or smart twins, or you can name it as you wish. The main idea of my presentation today is to demonstrate a project which concerns a twinning concept. The twinning concept is a concept that has been developed and proposed by the European Commission for the so-called widening countries. The widening countries are those countries in the EU, those EU member states that are considered not to perform very well in terms of research. So in terms of their metrics, these are those countries that have less budget in research, that have less research projects, and we have 17 widening countries. Lithuania is one of them. And the main idea of the widening projects and of the twinning projects is to assist, to support these countries, these member states, to improve their research performance by establishing collaboration with esteemed institutes from other member states which have better performance in research, the so-called non-widening countries. So this is overall the concept of the widening calls. And in our case, we discuss and we present this twinning project, which is based on digital twins for buildings. And actually, our research group is mainly in Kaunas, is mainly involved in the field of smart built environment, sustainable built environment. And our consortium in the case of this project consists of partners across Europe. So it's Kaunas in Lithuania, it's the Polimi, the Politecnico Milano, it's Contact, a spin-off of the Technical University of Berlin, it's CERT from Greece, the ITI Institute, which is based in Greece, and a partner from France for dissemination purposes in Innotrop. And the main idea of this project is to support Kaunas to improve its performance, its research performance in the field of digital twin technologies and in general for the digitization of the assessment of the built environment, the sustainability of the built environment in the fields of energy, smartness, and of course for concerning environmental aspects. Now, this is the main concept of the twinning projects presented in this slide. So the twinning projects, as explained, they are aimed to, let's say, link widening countries, so research institutes in widening countries with top-class leading counterparts across EU member states with the purpose to transfer knowledge. So the main idea of our project is that we wish to receive knowledge from established institutes across Europe for the field of digital twins. And a bit more specific on the twinning projects, twinning is not on the widening projects. Twinning are not the only projects that we have under this, let's say, group of calls. We also have the teaming projects, which they aim to establish research institutes across widening countries with budgets of 25 or 30 million euros. Usually it's each teaming project. We have the ERA chairs, is another form of widening calls. And we have the cost actions, which are under the widening costs. And in general, the main idea of the widening costs has been elaborated. Now, our project in a nutshell, you can see this infograph that includes all the essence of what we will conduct or what we are implementing in terms of smart wins. We have four, let's say, main clusters of activities. The first one, work package 1, is related to research activities, and this is the topic that I will focus today in my presentation. So I will mainly present the research activities that have been implemented by now in Smart Wins project. Something which is important to mention is that by definition, the widening projects are not research projects. So there is a limitation of 30% of the total budget for research activities. So in other words, we are not doing research. It's a coordination action. We are focusing on the other activities that are demonstrated in this slide as well. So we are focusing in training. You can see we have a work package which has different training activities, including summer schools, the development of curricula for digital twins, training sessions, interaction among the partners for training for digital twins. We also have a work package which concerns linkage with business. So under this work package, we organize brokerage events for digital twins, citizens events, where we demonstrate and we disseminate developments in the field of digital twins and buildings in Lithuania in order to get the input of the society, of the market, and to consider that for developing further research activities. And of course, we have a work package to improve the way we manage research, so for research management. And as said, the partners are shown in the slide. KTU is the leading partner, and we have partners across Europe, Polimi, CERT, Contact, and Innotrop that support this activity. So in terms of our research, and this is where I will focus and I will demonstrate some of the results that we have. We are, let's say, performing research in 4 fields. The first one is in the field of life cycle assessment, that is digitizing life cycle assessment and developing digital twin principles for conducting LCA. And I will demonstrate what we have achieved the past few months. The second one is in the field of indoor environmental quality. So we aim to develop our practices and to advance our practices in conducting IQ studies under controlled environment with our environmental chamber in KTU. We want to digitize the whole procedure and create digital twins infrastructure for this purpose. Also, the third task of the research component of the project concerns data management, IoT, digital twins for assessing the performance of smart buildings. We have some work there which is also going to be demonstrated. And the fourth task is a beam to BEP. So we do a lot of energy performance simulation of buildings in Kaunas. We want to align this with the BIM environment to integrate our practices and retrieve all the information that we need from IFC files. We will also discuss what we have achieved in that field. I will not go into detail for the other, let's say, work packages that I have here. The only, let's say, thing that I will keep from work package 2, and that is how we improve our research management, is task 2.2. So in terms of smart wins, we have the budget and we aim to organize a major event in Lithuania, a conference. And in collaboration and in communication with ED and BDTA, we aim to host the next BDTA conference in spring 25 in Kaunas. And this will be presented by Professor Jure Leonis right after this presentation. So he will present some details for the upcoming conference for 25 for digital twins. It will be hosted in Kaunas, Lithuania, in Kaunas University of Technology. So this is in terms of this project, the Smart Wins project that it is presented right now. And as said, activities for linking with the market and the business, and training activities, which I will not analyze in this presentation. Now, what concerns our research component, we said that we mainly have 4 tasks, focusing the first one in LCA and digital twins, the second one in IEQ and digital twins, the third one in IoT big data management. You can also see the leading partners in those. It's Polymi, it's CERT, and it's also Contact for the BIM to BEP, task. What we have achieved by now. Concerning the digital twins and the LCA, we were able, during this past 20 months, to develop a tool that performs LCA from BIM. That is a tool that can analyze information of the building from IFC files and IFC parser, that collects all the information that we need in order to analyze the performance of the sustainability performance of a building. We have also developed a data set of EPDs, that is environmental product declarations, and we have developed a tool that may conduct LCA from BIM files. And this has already been announced in a publication of late 23. And we have also used this tool in order to conduct the LCA assessment of typical geometries of buildings across Europe. So we have exploited some studies of BPIE concerning the EU building stock, how the buildings are developed and delivered across the European continent. We have developed typical geometries across Europe, and we have conducted, using this practice, that is a BIM to LCA practice, the LCA of different buildings across Europe, and this is also to be published in Energy Journal. It is expected. It's in the last stages of its publication, this study. Also, in terms of our work, we have conducted a detailed review assessment of the existing studies concerning geometric parameters and digital twins for assessing buildings. And we have published a study on that, so a literature review on geometric parameters to update digital twins in building assets. This study was published in the Journal of Building Engineering. This is also in terms of the project. It was one of the first steps that we did, and it compiles all the current developments in the relevant field. We have also done some work which concerns the assessment of the urban traffic, and with some predictive models in terms of assessing sustainable transportation in the built environment, which was also done under the Smart Wins project, in the sense of post-processing big data and using predictive models and machine learning towards extracting some, let's say, predictions on the performance of different, let's say, information that is related to the sustainable built environment. And this is also a study that was recently published in Smart Cities Journal. Other relevant work that was developed based on the Smart Wins project concerns the development of smart operational rating. This is another study that was published last year by the group, by the same people conducting the Smart Twins project. It concerns the performance of the operational rating of buildings with digital twin models, that is, with BIM models. And we see here the rationale of this approach. So we start with the physical asset. We convert that into a virtual model. We extract the information that we need from energy meters, and we are able to extract the required KPIs in order to develop the operational assessment of the building. At this point, it's important to mention that our group in Kaunas has also initiated, and it's currently coordinating, a working group under TC371. That is a technical committee for the energy performance of buildings. And this working group is working towards developing and delivering a standard for the operational rating of buildings. This is a non-exhaustive list of the indicators that we are extracting from this model. This is a case study that we have investigated, and we published the results out of that. You see here the physical and the digital model that was developed. That is the files that were used, let's say the backends that was developed in order to achieve this, let's say, post-processing of the measurements. And these are the results that were delivered for different indicators for different buildings using this model. So it's a totally completed and delivered model for the operational rating of buildings with the use of digital twins. Another example of the work carried out has to do with smart energy audits. That is a performance of energy audits with BIM files. This is a study that the first step was already developed and delivered. It focuses on the building shells, so the building materials that we have. From IFC files, we can extract information on the different building elements and components. We do the thermochemical analysis of these components. We introduce weather data. And based on some financial data that we provide, we are able to do the life cycle costing of the building and propose solutions for the energy upgrade of building. So this is the entire procedure of the energy audit, just conducted with the relevant data sets and just with an IFC file. So this, we see here the flow chart of the asset property values extraction of this model that was already finalized, and it's presented as well in Energy and Buildings, as well as a previous study that was demonstrated. That was as well a study that was finalized in late 23. You also see from the IFC document the attributes that we have used to develop this model. And these are some of the results and the interface that we use to show the results of the smart energy audit. And some other, let's say, graphs which demonstrate the parametric assessment and the performance of the different scenarios that we examine with this solution that we have developed. Okay, so I'm done. These are just some studies that were published, and I would like to call Professor Eurelionis to give some details for the upcoming event in Kaunas. Andrius.
Right. Just waiting for my slides to be on. So it's a pleasure to be here, and as Paris presented the work that we do in Kaunas, it's a very good place for me to just invite you next year to come to Kaunas. Here's where we are. If you don't know, we have two major airports in Lithuania, Kaunas and Vilnius. And Kaunas University of Technology is located in second largest city of Kaunas. You can fly to both. Kaunas has a smaller airport. Vilnius is more busy, but easier maybe to catch a flight there. So preliminary dates that we agreed upon is 7 to 8 May. And the idea is not only to do a conference, but also a brokerage event for Horizon Europe projects. We are currently in discussion regarding this, but hopefully we managed to secure this. The main venue will be our university, Santaka Valley. It's a building where business is connected with research. So part of the building is dedicated to research institute and part to startups and companies. And you can see how Kaunas looks like. So yeah, as Paris mentioned, this will be carried out in line with Smart Winds project. We have these 4 dimensions that Paris already discussed. This most probably will be the main topics of the conference, but the list can be extended, of course. And so far, I think from what Paris presented, you can see that our university is one of the leading ones, at least in the Baltics, in the topic of digital twins. We have many demonstrator cases with indoor, outdoor, the whole Kaunas city digital twin development, linkage with IoT data and things like that. So I hope that our colleagues from Kaunas University of Technology will present their research when you come. And that's it. Thank you very much. Hope to see you in Kaunas in 2025.
Thank you so much, and this is an invitation to be all together next year. So now we begin with the session 1. There will be 8 presentations, 10 minutes each one, about the sister EU projects for digital twin in the built environment. and how to build digital twin and case studies. So now is the turn of Bruno Fies from CSTV from France, and he will explain us about the beam to twin results.
Thank you very much. So, good afternoon, everybody. Very happy to be there. So, I'm going to talk about beam to twin, a digital twin solution to provide situational awareness for effective production control. So, European project that started almost 42 months ago. So, we are finishing this month after almost 4 years. So what's behind beam to twin? So we are focusing on the execution phase, and we would like to provide the managers with an overview of the situation of what's going on site, with specific focus on the quality of the work that is carried out. And when I'm talking about quality, it's about the quality of what is erected. I mean, in terms of positioning, are my beams, my walls at the right place? About the quality of the surface of what has been erected, the concrete that has been poured is okay in terms of surface. Are there any cracks on the surface that we can detect? But also the quality with respect to the timing, to the planning. Are my elements erected at the right time or not? Also, we focus on the worker safety conditions, on the optimization of the equipments, and we had also a module for predicting the site completion that is taking into account unforeseen events that may occur during the construction and propose alternative plannings. And after that, we make a decision to select one planning among the several that are proposed in order to react and take this event into account. So the idea is to having this continuously, this loop, comparing what is built against what was really planned. Okay, this is just a picture about the architecture. So the central component is what we call the DBTP, Digital Building Twin Platform. So this is more or less the brain of the system. This is where we have defined our central data model, our ontology. On this component, we have plugged 5 dedicated services focusing on volume control and process monitoring, surface control and process monitoring, safety control, equipment optimization, and the last one about the production planning. And all these services are provided with live data that are acquired from the site through different devices. LiDAR, we use, well, a reduced set of devices. In fact, LiDARs, camera, so fixed picture or videos, in order to analyze what's going on site. Then all these services are doing some processes, some analysis of these raw data, and they are sending back to the main component high-level information in order to provide this follow-up that is displayed through a dashboard. And of course, I didn't mention that we initiate that with the initial beam and the initial planning at the very beginning. Another view of what I just said, just to stress some particular points. So we initiate our system with the construction plan, with the beam. At the beginning, everything has been translated into graphs thanks to our internal model. So it has set up the as designed and the as planned models. And thanks to the other services, we build the as perform and as build models, and we compare them, and eventually we react on that in order to update the system. And then on top of that, with the dashboard we have developed, we are able to display 2D or 3D information thanks to the KPIs we have defined in the frame of the project. Okay, we deployed this system on mainly three countries, so in Finland, in France, in Spain, on different cases, so residential office building, on a renovation building, and on an extension of an hospital also in Spain. A few words about the consortium. So BIM2Twin, it's 17 partners across 8 countries, so from Israel to Finland. So you have the structure of the consortium, so with a balance of research technology centers, academics, contractors, technology transfer organizations, engineering companies, and IT firms also, like Orange and Siemens. Well, as we are almost at the end of this project, what are the lessons we learned, and the next step we were thinking about? Our DBTP, our main component, is suitable to provide this situational awareness that we promised at the beginning. So it means that, the fact that we are relying on semantic technologies was good in order to perform this kind of digital twin. The automated processing of the data, from the site, coming from the site, was really key in order to have quite agile system, so low latency between what is occurring on site and the fact that we are able to provide some reaction, to provide some alternative plannings, taking into account unforeseen events. And what I said already, the graph representation was working pretty well also to support that. But we have to keep in mind that as soon as we are working on a digital approach, on an integrated approach, we have really to focus on the structure of the data, on the coordination, how to produce these data, and spend the necessary time to understand the use cases that are behind the digital twin itself. A few words about the maturity of the technologies. So they were, if we think 4 or 5 years ago, they have evolved quite rapidly in terms of acquisition device, for instance, accuracy of the cameras, the LiDARs and things like that. And it's still evolving quite rapidly, but it was almost enough for us for what we deployed on our sites. We have been thinking also about future research tracks. If you think that BIM2Twin was really at the execution phase, so in the middle of a life cycle, so how to ease how to facilitate the transfer from the design to the execution phase. So we take into account BIM, we take into account the initial planning, but we were facing some difficulties to align both of these inputs. In the BIM, you have the description of the elements of your building. In the planning, you have the description of the task, but it's sometimes very difficult to understand where is my wall in the planning, in a sense. So you have to align that, and it required a lot of time and effort from our side. So this can be made more easy. At the end of BIM2Twin, you think that BIM2Twin will end with the execution and the construction of the building by itself, then you have to think about the next step, which is the operation of what has been constructed. And then we can think about, in a sense, we have here a kind of logbook, but we didn't think further than that. So how to reuse what has been recorded during the erection of the building in the best way. So also we have been thinking about more active safety around the workers and the equipments. And later, it's about how can we think about on-shelf solution, about digital twin, connected to a store of services that I'm able to pick and connect. And the last slide, just about more. So if you need some more information, we have a website, of course. You will find also recordings of a series of 5 webinars that were displayed last month. So you can have more information there. And thank you very much. That's it.
Thank you very much, Bruno. And now is the turn of Georgios Giannakis from Hypertech. He will be explaining us about Cogito and supporting the construction of infrastructure projects. Thank you very much.
Good afternoon, everybody. A pleasure to be here, and I'm here today assuming the role of the project coordinator of Cogito project, with the aim to present digital twin applications that we managed to develop and deliver within Cogito towards supporting the construction of not buildings but infrastructure projects, compared to the previous presentation that Bruno gave. So, our mission expressed by 6 objectives that we set within the project has been to craft a digital twin platform empowered by digital tools for quality control, workflow management, and health and safety management, demonstrated in actual construction infrastructure projects, present our results and try to collaborate in standardization activities, and promote our results through intense dissemination efforts performed within the project. So, fast forward 3.5 years of the project, and I'm thrilled to share with you that the consortium managed to deliver 14 digital tools, starting from digital tools that pre-process raw data captured on site, and I'm referring to point clouds and images, as well as location data, which actually is the only IoT data that we cover, that we processed from the field. Through those digital tools for pre-processing, make those data available to the digital twin platform. Upload also as-planned data, and by saying as-planned data, I'm referring to the B model, extended with the 4th dimension that covers the task's duration for the construction of those elements, but also scheduling information with the exact duration of each task. And then we do have 3 groups, main groups of applications. At the top, we see the tools that have been developed, 4 tools for workflow management. We'll go through those acronyms later on. 2 tools for geometric quality control. 3 tools for safety, for the safety context. And 2 visualization tools for on-site visualization through AR, and off-site visualization through a web application that has been developed. Okay, following an agile implementation approach within the project, we started demonstrating the tools that have been developed, early stages and versions of the tools that were developed in pre-validation cases. Actually, we did have 3 main pre-validation cases that you see on the left. The first one was the Autodesk project provided, the school project provided by Autodesk, tailored to the needs of the project. So there were some pre-processing steps to extend that project to cover the needs of the project. Then we had a non-operational tunnel in Athens provided by Olod and Olympiados, a partner that offers that tunnel to start experimenting with an IoT location tracking solution that is a Bluetooth low energy solution. Then we did have a pre-validation site, which was actually an actual medium-scale infrastructure project provided by RSRG. And as an outcome of these pre-validation activities, we did have updated versions of all our tools, enhanced with functionalities that cover additional requirements that partners or end users expressed as functionalities that would make sense to be included on such developed applications. The refined versions, the complete versions that the Cogito consortium delivered, were demonstrated in two large infrastructure construction projects, actual projects. The one in Germany, which was about a metro extension in Munich, and a second one, a linear infrastructure project in Murcia, Spain. So let's have a look. I know that I cannot explain everything in detail that you see here. The time is quite limited, and I will be happy to cover any questions that you have afterwards. We can see together also some of the tools that have been developed. I do have access as coordinator to the majority of them. Starting with the health and safety tools, actually we did develop three main tools. The first one was about making the BIM model safe. So actually here, the SafeCon AI tool, which was about that, takes as input the BIM file, the as plant BIM file, and applying various algorithms and compliant with regulations per country, try to enhance the BIM model with safety elements. Not only safety elements, but also detecting, identifying, and enriching the IFC file, the BIM file, with safety zones. For example, what are the areas that seem to be hazardous for the workers, and try to prevent them through such information being available in BIM. So, a result of the SafeCon AI was a safe BIM that includes the elements that I mentioned before. After that, we did have an application that was about detecting risks and alerting workers on site accordingly. Here, actually, we consume information from location tracking solutions that we have on the field, GNSS solutions and RTK GNSS solutions, and BLE that I mentioned before. Process the data, consume not only such data but also the safe BIM, and try to alert workers for their proximity in hazardous areas, but also providing some insights on how often the workers violated the limits that set with regards to those hazardous areas. The third application for health and safety management was a VR application that was developed to educate workers for health and safety aspects. Here we consumed both the safe BIM but also results from the proactive safety component. And we created game scenes in that virtual reality environment. And based on that, we tried to educate the end users, the workers, about health and safety aspects. Providing them also some insight about KPIs that were calculated for their score, how well they performed on that virtual reality environment. Talking about the quality control, actually here we did have develop 4 main components. 2 of them offer a UI. The first one was about collecting and pre-processing the images information but also the point clouds and make them available to the digital twin platform to be later consumed by other applications. Two services that do not offer user interface, but are services that rank as a backend solutions for detecting a violation of tolerance that we set based on the regulations. And this is the geometric QC, where actually it compares the point cloud data with the B model. And the visual QC, visual quality control tool, where actually this tool applies machine learning algorithms and try to detect defects on already erected components. And the third component is an AR component that is about not only collecting images from site, but also visualizing quality control results. Talking about the workflow management components, three main components have been developed and delivered. The first one was about processing the original schedule and the beam data so as to optimize the tasks that have been assigned for the erection of this its infrastructure project, and setting different objective functions. Then evaluate and simulate the results, selecting that output file as an enriched schedule information, where actually as part of this tool we also enrich the schedule with quality and control tasks, but also health and safety tasks, which are missing from the original schedule information. Then this information is being consumed by another application that is called WODM, Work Order Definition and Monitoring Tool, where actually this tool is responsible for assigning specific resources to the tasks that are about constructing the infrastructure project, and at the end an application that assists and supports the workers on site to report progress on the construction of its infrastructure project. Talking about the data management process, count the times that I mentioned digital twin platform, DTP, and you realize that the orchestration of all those tools will not be possible without a middleware. And this middleware is actually the digital twin platform. I know that I'm a bit behind schedule, just to highlight the fact that this tool is about orchestration of all the components that we saw earlier. It's also about securing access to the data that the tools are being developed through user registration and role assignment functionality. I'll not talk about the data persistence layer, but let's move to some of the tools, ETL tools, extract, transform, and load tools that are integrated in the digital twin platform, which are about the knowledge graph generation, where actually is a tool that ensures data harmonization of the tools, of the data generated by the tools, but also perform the validation of the tools that are being generated, and other ETL tools like the boundary representation generation tools and the geometric the geometry checker. Actually, this is the last tool that I would like to showcase. It's the offsite data visualization tool that I mentioned. You see here that this is actually the single point where we are consuming the data stored in the digital twin platform. We have developed a tool where we can represent the different digital twin application results with overlays on the BIM model. Closing this presentation, I'd like to mention that the consortium managed to deliver 14 deliverables that detail the functionalities that are offered by all these tools. I'd like to mention also that those deliverables are accessible through our website but also through our community in Zenodo. Some things to highlight is that we developed and delivered 10 manuals for the cognitive tools that offer a user interface. And finally, to make sure for potential end users that they fulfill the requirements of the project with regards to data collection, we managed to collect all the guidelines for the as-planned and as-built data acquisition in a single document that is titled Guidelines for the as-planned and as-built data acquisition. And that was me. Thank you.
Thank you, Georgios. We know who will pay the beer tonight. Okay? Georgios, be prepared. So it's time for Dr. Sanju Tiwari. She's coming from New Delhi, so thank you for coming. And she will explain about digital twins status in India.
Thank you. Thank you everyone. And, it is a pleasure to be here. So today I am going to present about the digital twin landscape in India, that is current status and future prospects. So, I am Dr. Sanju Tiwari. So first of all, namaste to all. And I am former recipient of DAT AI-NET postdoctoral. I also have a lab, and as a CEO, I have founded this lab. As a professor, I am in BDTIC, New Delhi, India. So today, these are the content, the digital twin for India's future. I will cover these points: Indian construction and infrastructure, national infrastructure pipeline budgets, maturity level, investment opportunities, challenges, and initiatives in India, along with recommended strategies. So digital twins, as the BIM is a foundation of the digital representation, and digital twin next step of it. And there are some definitions are already given by the ISO and UK BIM task group. So just to introduce about it. And there is a huge potential in India about the for the digital twins, and they are the major 5 domains where they can play a very significant role. So city management, it can be used for the modeling and simulating the different urban planning and development scenarios. Infrastructure development to plan and design in the construction for the new infrastructure project, mobility and supply chain to optimize the logistic and transportation like ports, railways, airports, defense and security to simulate and analyze military operations and scenarios. And the last one is emergency management to model and simulate various scenarios like natural disaster and terrorist attacks, accidents. So now in this slide, I am going to highlight about the Indian construction and infrastructure. So the India has to be the 3rd largest construction market in the world by 2025, as with an estimated value of around 1.4 trillion USD, as this sector is contributing 9% to the GDP and employing approximate 51 million people annually. And it was the 2nd largest FDI recipient for the 2021. And the vision of Indian government for the 2025 is aligned with the United Nations 2030 Sustainable Development Goal, that is to build the world-class infrastructure projects in the country. So government plans to build twins. So these are some schemes launched by Indian government for the Indian construction and infrastructure: the National Infrastructure Pipeline, the National Monetization